Welcome to The Explainer. This is where we break down, well, big ideas. And today, we are tackling a really powerful statistical tool, the binomial distribution.
All right, here's the plan. We're going to start with a real-world puzzle, then meet the tool that solves it, learn its rules, see how it actually works, and finally figure out why it matters in the grand scheme of things. Okay, let's dive right in. So, let's kick things off, not with some dry theory, but with a question that has, real stakes. Something that could actually impact people's lives.
Okay, so check this out. A new drug has a 90% success rate. If you test it on 8 patients, what's the probability that exactly 7 of them respond positively? Now, this isn't a trick question, right? It's a real probability puzzle that pops up all the time. In science, in business, you name it. So how do we find that precise answer?
To solve puzzles just like that one, you need the right tool for the job. And in this case, that tool is the binomial distribution.
So what is it? Put simply, it's a probability tool. You use it to find the chance of a specific number of successes in a set number of tries. But here's the key. Each try only has 2 possible outcomes. Like heads or tails, pass or fail, yes or no. It's the perfect tool for any this or that situation.
And the whole thing is built on this one simple idea, the Bernoulli trial. It sounds kind of fancy, but really, every single event, one coin flip, one patient in a trial, that's a Bernoulli trial. It's just an experiment with 2 possible outcomes. That's it.
Okay, but here's the catch. You can't just use this tool whenever you want. Nope. It only works if a situation meets 4 very specific conditions. Let's break down what those are.
All right, think of these as the 4 commandments of binomial distribution. First, you need a fixed number of trials. You have to know you're flipping a coin 10 times, not around 10 times. Second, there can only be 2 possible outcomes. It's got to be success or failure, heads or tails. That's the buy in binomial. Third, the trials have to be independent. The last coin flip can't magically influence the next one. And finally, the probability has to stay constant. The chance of getting heads has to be 50% on the first flip and the last flip. If your problem checks all 4 of these boxes, you're good to go.
All right, now for the formula itself. And I know, formulas can look a little intimidating, but stick with me because this one actually tells a pretty simple logical story in 3 parts.
Okay, here it is. P of x equals r just means the probability of getting exactly r successes. Now let's pull apart what each piece of this puzzle is doing.
So part 1, this bit right here, it's not even about probability yet. It's just counting. It's figuring out how many different combinations of, say, 7 successes you can get in 8 trials. It's all about the arrangements.
Okay, part 2. This is the probability of your success streak. You're basically taking the probability of one success, P, and multiplying it by itself for every success you're looking for, R. It's the odds of just one specific winning sequence.
And finally, part 3. This is the flip side, the probability of the failures. You take the chance of failure, which is just 1 minus p, and you account for all the leftover trials. So you see, the formula just multiplies these 3 pieces together, the number of ways, the probability of the successes, and the probability of the failures, to get your final answer. It's actually pretty elegant when you see it that way.
All right, enough with the theory. Let's go back to our opening question and see this thing in action. This is the payoff.
So, that question about the drug. What's the probability of exactly 7 out of 8 patients responding? Well, you run the numbers through the formula and you get 38.3%. Boom. The binomial distribution gives us that precise, really powerful answer.
And once you know what to look for, you start seeing this tool everywhere. Think about it. In a factory, what's the probability of finding 3 defective items in a batch of 100? That's quality control. Or in politics, predicting the likelihood a candidate gets a certain number of votes. Even in business, analyzing positive versus negative reviews, it's all the same underlying logic.
And you can even visualize this stuff. Take a really simple example, flipping a coin twice. This chart shows it perfectly. As you can see, the most likely outcome is getting 1 head, right? That's a 50% chance. Getting 0 heads or 2 heads, well, that's less likely, only 25% each. This bell-like shape, that is the classic signature of a binomial distribution.
Now, what if you don't need the exact probability for one specific outcome? What if you just want the most likely average over the long run? Well, there's a handy shortcut for that called the expected value. The formula is super simple, just n times p.
So for, say, 20 coin flips, the expected number of heads is just 20 times 0.5, which is 10. Simple, right? But so powerful.
So we've seen what it is and how it works. But let's zoom out. Why does this one statistical tool matter so much? What's the big picture?
Well, it really matters because it's about using the right tool for the right job. You wouldn't use a hammer to saw a board, right? We all know about the famous bell curve, the normal distribution. That's fantastic for continuous data, stuff you can measure like height or weight. But the binomial distribution, that's our specialist. It's our go-to for situations with a fixed number of distinct yes or no trials.
Ultimately, what does it give us? It gives us a reliable mathematical way to quantify uncertainty. It helps us make really informed predictions in a world that is just full of binary yes or no outcomes, from medical research all the way to manufacturing.
So, now that you have this tool in your toolkit, think about it. What probabilities in your world could you start to predict? What's the chance of hitting 5 green lights on your way to work? Or, maybe if you're in sales, the odds of closing 3 deals out of 10 calls. The world is absolutely packed with binomial problems. And now, you have the key to start solving them.